Alrighty, this is going to be the last lecture video in our pre-calc course. So we'll be talking about lesson 12.3, geometric sequences and series. And just like arithmetic, once you have the formulas, it's all about using the formulas to answer the questions that are being asked. So the big things on this one is your geometric sequence formula. It's going to be a sub n equals a sub 1 times the r, which represents the ratio, raised to the n minus 1. To find the sum of the nth term, it'll be s of n equals a sub 1 times 1 minus the ratio raised to the nth power divided by 1 minus r. And then if you're looking for the sum of an infinite geometric series, again, just like before, you need to determine if something like this is converging or diverging. To do that, if r is less than 1, really and truly the absolute value of r, let's do it like this. Let's say -1. So as long as r is between 1 and -1, it will converge. And if it converges, the equation for that would be s equals a sub 1 over 1 minus r. If r is greater than, let's go with the absolute value this time, than 1, then it will diverge and it won't add up to anything. And so that is pretty much the rest of your notes there for the rest of this chapter. So let's just do some examples so you're prepared for the homework, which will then prepare you for the last test, which will then prepare you for the final. All right, here we go. So on number 2, you are given the sequence of given 7, 7/2, 7/4, 7/8, 7/16, and so on and so on. So you're asked to find the equation, which remember is a sub n equals a sub 1 times r raised to the n minus 1. Remember, this is still your a sub 1, a sub 2, and so on and so on. To find your ratio, all you have to do is take a sub 2 divided by a sub 1. So in this case, you just do 7/2 divided by 7. And you will see if you keep, change, flip, you get 1/2. That means you are multiplying by 1/2 each time, which makes sense. So then once you have your a sub 1 and your r, you simply just plug it in. So this will be 7. Typically, you'll see it written with parentheses. That'd be 1/2 as the ratio raised to the n minus 1. And that's it. Let's do a few more. Let's look at number 3. Number 3 is 2 -2/3, 2/9, -2 over 27, and then 2 over 81. Again, let's start off by finding our ratio. So -2/3 divided by 2. So that's -2/3 times 1 over 2, because you keep, change, flip. So that would give you -1/3. And again, you might be able to obviously see that. And then again, this would be your a sub 1. So therefore, your formula would be 2 times -1/3 raised to the n minus 1. Done. And what's nice about this formula, with arithmetic, we had to simplify. This is its simplest form. All right, let's look at one that you're still asked to do the same thing, but given different information. So this one is a sub 1 equals 5 and a sub 4 equals 40. Now, to find the ratio here, if you look back in example 2 in the book, it kind of goes into a little bit more details. But basically, if you know that 5 will equal whatever a sub 1 times the first ratio is, actually that would give you, um, so that would be n minus 1. So that would be 1 minus 1, which would be 0. So then you see that 5 is equal to a sub 1 times r. So 1 minus 1 will be 0. And so that'd be 5 equals a sub 1 times 1. So therefore, we're basically just proving that a sub 1 equals 5. But using that same idea, we can kind of go with this route. So define the ratio here using the formula. We can kind of figure this out. So a sub n, we know, is 40. A sub 1 would be 5. My ratio is unknown, and this would be 4 minus 1, because the n in this situation is going to be the 4. So then I get 40 equals 5, and then r cubed, divide by 5. So you get 8 equals r cubed, and then we can take the cube root. Therefore, we see r equals 2. I was using this at first, but as I was working it, once you have a sub 1, you really don't need this part. You can just go to this part, but there is some situations, and we'll see that in another problem, where you're not given a sub 1, and I'll show you how to do that too. But now that you got the ratio, now you're ready to plug in the equation. So this will just be 5 times 2 raised to the n minus 1. There you go. Let's look at a different one. That was number 4. So let's look at number 7. All right, number 7 gives you a sub 2 equals 1/7, and it tells you the ratio is 1/7. So all you gotta do now is kind of find a sub 1. I'm gonna show you a longer process. Obviously, if I multiply by 1/7, I could just divide by 1/7 and get the answer. But what if this wasn't a second, and maybe this was a subscript 7? So let me just kind of illustrate using this formula. I'm trying to calculate what a sub 1 is. So using a sub 2, so that's going to be 1/7 equals a sub 1 times 1/7. And this will be 2 minus 1. So this would be 1/7 equals a sub 1 times 1/7 raised to the 1 power. So this is 1/7 equals a sub 1 times 1/7. Again, you could skip a lot of these steps. But then to get rid of this fraction, I'm going to multiply by 7 over 1, multiply by 7 over 1. And that happens to tell me that a sub 1 is equal to 1. So to write this out, I would say a sub n equals 1 times 1/7 n minus 1. The issue here is we don't typically write the 1. So you'll see it written more like this. And then we know that the starting is 1. All right, so that is a long process when you could have just simply multiplied by 7. But again, what if it would give you a to the 7th? I want you to be able to have a good example to find all of them, not just those situations. All right, let's look at one more of this type. We're going to look at number 18. So this would be a sub 4 equals 8, a sub 8 equals 128, and r is greater than 0. So this just tells us we don't have to deal with negatives. That's really all that's highlighting. But this is what I was trying to illustrate on number 4. So in this case, using that formula, I can say this is 8 equals a sub 1 times r raised to the, this would be 4. So that would be 4 minus 1. And then this would be 128 equals a sub 1. And this would be r 8 minus 1. So if I wanted to produce a ratio, I could do 128 over 8, which would be the same thing as a1 r to the 7th divided by a1 r to the 3rd. The a1s would cancel, so this would basically give me, to simplify exponentials, you just subtract. So 7 minus 3 is 4, so this gives me r to the 4th. And then I would figure out what is 128 over 8, and then I would do the 4th root of that. All right, so this is definitely going to be a calculator question. So let me show you how to plug that into a calculator if you do not know already. So when I come over here to my handy dandy calculator, let me make sure you're seeing that. Okay, perfect. Okay. And so what you'll do is you're just going to do control rooftop. This allows you to put different roots in. So this would be 4. And then I would go in, do control divide, 128, don't forget the rest, over 8. And there you go. And this happened to be 2. So that's great. So when you come back, this will give me 2 as my answer. So there's my ratio. The only issue now is now I got to figure out what a sub 1 is. And you can use either one of these equations here to figure that out. So I'm going to stick with the first one, but you could use that one too. So this time I get 8 equals a sub 1 times 2. Oh, that's an R still. Times 2 raised to the third power. And so then I see that 8 equals a sub 1 times 8. And then I'll divide both sides by 8. So I see that 1 is equal to a sub 1. So therefore, my equation would be a sub n times or equals 1 times 2 raised to the n minus 1, which is really just 2 times 2 raised to the n minus 1. All right. And again, a lot of times you'll see it with the parentheses, but same concept. Right, so there is a little bit more work when you're not given a sub 1 or you're not given the ratio and things like that. So that gives you a couple examples to look on that one. So let's look at a different type of question. So let's look at number 33. Use the given information about geometric sequence to answer the question, answer the following question. So you're given a sub 2 equals negative 5 halves and a sub 5 equals 5/16, and you're asked to find a 15th. So basically what we're going to do is do exactly what we did earlier to get our equation, and then we can just plug 15 in so we're not just having to repeat the math over and over and over again until we get to the 15th term. All right, here we go. So to do that, to find my R, remember it's just going to basically what's going to be, it's going to be 5/16. So it's going to be the last term that you have divided by negative 5 halves. I'll tell you what, let me just write it all together so you can see it. So this will be negative 5 halves equals a sub 1 times R raised to the 2 minus 1. This will be 5/16 equals a sub 1 times R to the 5 minus 1. So then I would do 5/16 divided by negative 5 halves. And that would give me a sub 1 times R to the 4th power over a sub 1 times R, just R. So that would cancel a sub 1, and then I'm left with R cubed. And then if I keep change flip here, so that's 5/16 negative 2/5. So the 5s would cancel. That would really down to 8. So that gives me negative 1/8. So I really have R cubed equals negative 1/8. Take the cube root of that. So the cube root of negative 1/8 happens to be a negative 1/2. So the cube root of 1 is 1, cube root of 8 is 2, and the negative does carry with an odd index. All right, so there's my ratio. Then I can use that to help me find a sub 1. And again, I'm going to use that first formula, but it doesn't matter. So negative 5 halves equals a sub 1 times negative 1/2 raised to the 1 power. So in this case, I'm just going to multiply by negative 2, 1 to cancel this out. So I'm going to multiply this one by negative 2, 1. The negatives would cancel, the 2's would cancel, and I'd be left with just 5. So a sub 1 would equal 5. So now I have an equation of a sub n equals 5 times negative 1/2 raised to the n minus 1. But now I'm looking for the 15th term. So a sub 15 will equal 5 times negative 1/2 raised to the 15 minus 1. This is 5 times negative 1/2 raised to the 14th power. You can do that math if you want. I'm going to simply just plug that into the calculator. Make sure you do a parentheses, because that's going to matter. And then remember to do a 14th power. You just hit the rooftop. You don't have to hit control. That's only if you're trying to do a root that's higher than square root. And then you just hit enter and you actually get, I got 0.000305, and that's because I did turn -1/2 into a decimal. I don't know if it takes the decimal. It might want this as a fraction. So the fraction form of that will be menu, numbers, convert or approximate to fraction. And I actually get 5/16,384. So I think it takes the fraction. It should take both, but just in case, there's how you can do fractions as well. All right, let's look at another one. So let's look at number 36. This one is given ace of 2 equals 24 and ace of 5 equals 375. You're just asked to find the common ratio. So again, to do that, that's going to be 24 equals ace of 1 times r raised to the 2 minus 1. And then 375 equals ace of 1 times r to the 5 minus 1. So this is going to be 375 divided by 24 has to equal ace of 1 times r to the 4th over ace of 1 times just r. So that would cancel. So I get just r cubed has to equal, well, what is 375 divided by 24? All right, that gives me 15.625. I'm sure it's a fraction as well. Take the cube root of that. So then the cube root of that, 15.625, will give me 2.5. Again, if it wants it as a fraction, that would just be 5/2. Not quite sure what it wants to go with that, but then that's what I would do. So then I got the ratio either as a decimal or as a fraction. The notes I wrote down from your homework, it gave it as a fraction. Alrighty, so looking at number 42. Number 42, you're given the sum of 40, I equals 10, and then 2 to the I. You're asked to evaluate each following sum or a partial sum depending on what you're dealing with. In this case, I could plug in 10, 11, 12, and add those up, but this is where I'm going to use that equation. So that would be S of n equals a sub 1 times 1 minus r sub n over 1 minus r. So to start, I'm actually going to find what is S of 40. So to do that, I need to find a sub 1. So that would just be plugging in 1. So that'd be 2 times 1, which would be 2. All right, so a sub 1 would be 2 times 1 minus my ratio. Wait, is that 2 to the ith power? Just, oh, yep, hold on. Bad handwriting. So this is 2 to the ith power. So that'd be 2 to the 1, which, okay, still 2 though. So 2 minus 1, the ratio is this guy right here. It's the one that's in parentheses. So this would be 2 raised to the 40 over 1 minus 40. So I'm just going to type that into the calculator. So give me 2 times parentheses 1 minus 2 raised to the 40 over 1 minus 40. Ooh, that gives me a pretty big decimal. Oh, I did not mean to put 40. It's 1 minus r, the ratio. The ratio is just 2. All right, let me try that again. Back over here. All right, that looks a lot better. So you actually get 2,000, well, I don't even know. That's millions, trillion, millions, billions. So 2 trillion and something. But that's for all 40. Notice this is I-10. So I also need to go find S of 10. Actually, S of 9. So I can take that first 9 terms off. So that'd be 2 times 1 minus 2 to the 9th over 1 minus 2. When I do that, I actually get just 1,022. So I'd actually subtract these two totals. And your actual final answer would be 2,399,254,528. There you go. So that would be your answer there. So when it doesn't start at 1, you do need to take off however many it's not part of your sum. All right, so let's look at another one of those. So let's look at number 46. This one you're given 1 minus 3 plus dot 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 plus 59,049. All right, to figure this out, you need to be able to write out your sum. So you need the ace of 1, the ratio, and the term. So nicely, we have the ace of 1 already. The issue is we don't know the ratio, but we can figure that out pretty quickly. We can take the second term, divide it by the first term, and that just happens to be -3. So I have my ratio, I have my ace of 1, but I don't know what n is. So to figure out n, I'm going to plug in the last term here, and I'm going to set it equal to my ace of 1, which is 1, times my ratio, which is -3, raised to the n minus 1. So to calculate this, this will be 59,049 equals -3 raised to the n minus 1. Let's see. Easiest way to do this. And I feel like we've learned a lot, but I've also taught a lot of courses this go around. Did we ever talk about logarithms? As if I'm waiting for y'all to respond. Let me look. Anything expected that you already knew? Oh, good. We did talk about logarithms back in chapter 6. All right, so this will make this a little bit easier then. So what we're going to do is going to do the log roll here. So this is going to be log b of, I never got the formula now, but log b of x equals a, or maybe it was y. It was y. And this is basically just going to be b to the y equals x. That part, I just don't remember how the letters worked out for us. So this right here is going to technically be my x. This right here is my b. This is my y. So this becomes log of -3 of 59,049 equals my y, which was n minus 1. So to find n, I just do this plus 1, because then that would give me my n. All right, so I'm just going to plug that into the calculator. So remember, do logs. It's going to be control 10 to the power of x, which is the button next to the 1. I'm going to type in my -3 and then 59,049. Ooh, can't do -3s. Yay. Can I pretend it's a positive and still get an answer? Let's look at that. And if I add 1 to that, I get 11. Would 11 be my answer? So let's look at that. -3 raised to the 11th. No, but we could do ten. Okay, so why is it that I did that and it gave me 10? All right, so the math. Okay, so I know here I could separate this. So n minus 1 could be 3 divided by the negative 1. Interesting. All right, so okay, so this would be negative 3. We plugged it in here. We didn't get an answer, but we did get an answer when we plugged in just 3. And it has to be somewhere like this has to be something like negative 3 to the nth divided by negative 3. Oh, there it is. Okay. And so then from here, then they multiplied this by negative 3, but then this would be negative. Can you take a next? So hold on. Try and give you a mathematical explanation here. Okay, so you take that. So then we'll say now this is a 3 raised to, or taking the negative 1,000. I don't think do this either. Yeah. Can't have a negative inside for sure. Again, maybe the negative only goes on one of them. That would give you 11. All right, so here's just going to be my rule of thumb. I bet it works every time. Maybe we can do another one. To plug it into this form here when we do the logarithm, we're going to do the absolute value of our b. So whatever this is, we'll make this a 3. And then that will pretty much just give us the answer. So basically log base of 3 of this, and you don't have to worry about the plus 1 there, and that would be it. I like to do another one to make sure, but this gives you n equals 10. And the reason I know that because I can plug in 10. No, it would be 11 because so I'm glad I don't want to just delete something just to delete it. Right. So I need the 10. So okay. So yeah, so you'll have the minus 1. We'll add 1 to both sides. In this case, we actually got 10 plus 1. So therefore, n does equal 11. So this would be the 11th term because an 11 minus 1 gives us the 10. That would give us this result. All right, so again, so rule of thumb, when dealing with this logarithm, let's just do the absolute value of this. It gives us the correct answer. I know it has still somewhat that negative. But we'll just do this as a rule of thumb, and then hopefully we'll see another one perhaps like this so we can do another example. So with that, I can now do my equation. So that was S of n equals a sub 1, which is 1, times the 1 minus the ratio, which was negative 3, raised to the 11th power over 1 minus the negative 3. So again, I'm just going to plug, I don't know why I put 2 negatives there. The negative 3. There you go. All right, so now I go back and I plug it in. So control divide. Eventually, there we go. So that'd be 1 times the parentheses, 1 minus, again, parentheses, negative 3, close parentheses. We will raise that to the 11th. And then this would be pretty much 1 plus 3. And we get a grand total of 44,287. And you got to realize it's being added and subtracted over and over again. All right, so that was a good problem to see so that if you end up in that situation, you can see why. All right, so let's look at another set. So let's look at number 49. This one is talking about infinite series. So this is going to be I equals 0 up to infinity, negative 1/2, 2/3, I. All right. So in this case, let's see. I see that my ratio is less than 1. So this definitely converges. And to figure out what it converges to, I just simply need to do a sub 1 equals 1 minus r. This is going to be your a sub 1. This right here would be your r. So in this case, I'm going to do negative 1/2 over 1 minus 2/3. You can type it in the calculator if you would like, but this is just going to be this, which is negative 1/2 times 3 over 1, which gives us negative 3/2. Again, from this point, you can type it in the calculator. But this is the ratio. Since it's less than 1, it converges. The first term is the a sub 1. If there's not a number, remember, it will be a 1. All right, so let's look at another one. So let's look at number 50. This is going to be I equals 1 to infinity, and then 4/5 I. Again, r is less than 1, so it's going to converge. And if it converges, it's going to be an imaginary 1 there. So that's 1 over 1 minus 4/5. So that's going to be 1 over 1/5, which will then just be 1 times 5, which is 5. So this right here would converge to 1 minus 1 4/5 is 1/5. But you know what? I don't think it's a 1. This started, I didn't even see it. This started at I equals 1. So that would mean that 4/5 raised to the 1 is 4/5. So this is the actual first term. So scratch that. The first term is 4/5. So we need to pay attention to that little indicator. Where did it start? So 1 minus the ratio is still 4/5. So this will be 4/5 over 1/5. So this will be 4/5 times 5 over 1, which just gives us 4. So that would be the ultimate answer. So again, I'm glad we are seeing these type of problems so that if you have issues with it, you can see how to get through it. All right, let's look at number 55. This is going to be infinity, I equals 1, 1/3, 2, I minus 1. Again, I don't even have to do math. This is the r. It is greater than 1, so this diverges. And since this diverges, you can't get into anything else. So we're actually done there. So let's look at another one. Let's look at number 58. Number 58 asks you to write the decimal as a fraction. So to do this, you have to kind of work this a little backwards. And if you actually look at example 5b, it does a pretty good job of explaining what this becomes. So this right here would be the same thing as 165 over 100. And then you would just add 65 of every like 100 times. So this would be then, I need 4 zeros. This would be 6,000 or 10,000. This would be 65 and 1 million. And so on and so on. So to do this, this will actually become the series of n equals 1 of this guy right here. You're doing, you're not multiplying it. I guess you are. So this would be know the ratio is going to be 1/100ths. To the n minus 1. So I assume that's going to be our first number. So 165 over 100. So here we go here. So then when we work this out using our equation, this will be 165 over 100 divided by 1 minus 100. So now I get 165 over 100. And then this would be 99 over 100. And this is then 165 over 100. Flip it, 100 over 99. So therefore, this guy as a repeating decimal would be 165 over 99. They got 164 over 99. How in the world would they do that? You know what? Let's plug it in. Again, I might have used the wrong first term, which I did earlier. So that would be 165 over 100 times, no, because that would be, you plug in 1, that would give you 0. That would be it. Hmm. 99 over 100 on the bottom. First term is going to be that. Next, you just add 0.65 each time. Now I'm curious. So if I type in 165 divided by 99, well, I do get 4 5/3. So then 164 divided by 99 gives me that repeating decimal. But why is it a 164? So let's look back at that 5b. They just took this part out. Okay, so let's try that. Let's use that as our guide. So if we use that as our guide, then I would say this is going to be 165, and then say this is 1/100ths. Or is it the fact that this 1, I bet that's it. So I bet they did it more like this. I bet it's going to be 1 plus 65 times 1/100ths of an n. So if we do that and we plug in 1 into this would give me 6,500. So this would give me, sorry, my ace of 1 would be, well, we'll just say 165 over 100. Oh, okay, if we do that, because you plug in 1, you get 65 over 100, which is then 1 plus that would be 165. That's still your first term. That's still your ratio. But there's a 1 here that we have to compete with. So I wonder if we can use our facts and say that this is going to be the same thing as this. That 1's really throwing me off. Oh, I see. All right. So this actually, we're just going to trash this. So let's look at number 58 again at the beginning. So for 1.65 repeating, if you actually look at Zeno's paradox, you can actually write this out as 1 plus 65 over 100 plus 65 over 10,000 and so on and so on. So then when we do our formula here, the first term is actually 1 divided by 1 over hundreds. No, because you're dividing by 10 each time. So this would be, okay, so 1, would it be 165? Let's do that. So this would be 165 over 100. And that would give you 1 over 65 over 100. Because that would be sort of negative. No, because then that'll give you, ooh, that's a good one. Hmm. Because I mean, we got it pretty much down. We see that our first term is going to be 165 over 100. And then if you divide that by 1 minus 1 over 100, that would give you 165, 100. That would, we already determined that that would give me 100 over 9. This will give you 99 over 100. And then you should get 165 over 99, but this ends up being 1 less. And I don't know why. Does it work like that on every single one of them? That makes sense. Let's look at number 61. Number 63, 989. There's no pattern that I see. We could easily just get the answer too. I'll have to spin back to this one. Um, Other than this one, though, if you end up with any other questions, let me know and I'll come back to this one. I would say see you in the next video, but there won't be one. So good luck on your test. And as always, if there's anything else I can do to help you out, just let me know.